Hi friends, today we will discuss about eigenvalues and eigenvectors. How to find eigenvalues and eigenvectors of a given matrix. So let us consider this equation, matrix equation A11, A12, A13, A1n, 21, A22, 23, 2n, 31, 32, 33, 3n, like this, an1, an2, n3, and x1, x2, x3, xn equals to y1, y2, y3, y. So this equation can be represented as ax is equals to y, where A is a matrix, this matrix A of order n by n, x is a column vector and y is also column vector. So now consider this equation, A minus lambda I into x is equals to 0. Thus the unknown scalar lambda, the unknown scalar quantity lambda is called eigenvalue of the matrix A, and the corresponding non-zero vector x is called eigenvector of this matrix A. Now, how to find the characteristic equation? What is the characteristic equation of this matrix? So, the equation of A minus lambda I modulus. This is the mod of A minus lambda I equals to 0. This is called characteristic equation of matrix A. Now the question is how to find eigenvalues or characteristic roots. So the roots of the characteristic equation A minus lambda I equals to 0, modulus of this, are called the eigenvalues or characteristic roots of matrix A. Now let us consider an example. How to find the eigenvalues or eigenvectors of a given matrix. Say, find eigenvalues and corresponding eigenvectors of matrix A equals to, say, 5, 2, 2. Let us consider this 2 by 2 matrix, and we have to find the eigenvalues and the corresponding eigenvectors for a given matrix. So first of all, we will find out the characteristic equation. So characteristic equation of this matrix A is given by A minus lambda I mod of this equation is equal to 0. First of all, we will calculate A minus lambda I. A minus lambda I can be calculated as 5, 2, 2, 2 minus lambda and 1, 0, 0. This is an identity matrix. Now we can simplify this. 5 minus lambda, 2, 2 and 2 minus lambda. Now the characteristic equation of this matrix A minus lambda I is equals to 0. That is 5 minus lambda 2, 2 minus lambda is equals to 0. Now simplify this determinant. So 5 minus lambda 2 minus lambda minus 4 is equal to 0. Now find the characteristic equation of this matrix. So 5 into this is 10 minus 5 lambda minus 2 lambda plus lambda square minus 4 is equal to 0. So this is equal to lambda square minus 7 lambda plus 6. So this is the characteristic equation, that is lambda square minus 7 lambda plus 6 is equal to 0. So we can factorize this equation and we can find out the eigenvalues or characteristic roots of this equation. See, lambda square minus 6 lambda minus lambda plus 6 is equals to 0. So this is lambda minus 6 lambda minus 6 and lambda is 1 equals to 2. So lambda equals to 1 and 6. These are the eigenvalues. So eigenvalues for the given matrix are 1 and 6. Now the question is how to find the corresponding eigenvectors for this matrix. So, to find the eigenvectors, first of all, we must consider the equation A minus lambda I x is equal to. See, what is A minus lambda I? A minus lambda I is 5 minus lambda 2 minus lambda, and say this vector x is x1 and x2, and this is equals to 0. And now for the given eigenvalues, we will find out what are the corresponding eigenvectors. First, when lambda is equals to 1, put this value lambda equals to 1 in this equation. We will find 4 minus 1, 5 minus 1, that is 4, 2 and 2 minus 1, that is 1. x1, x2 is equals to 0. Now, simplify this equation. See, 4x1 plus 2x2 is equals to 0, and 2x1 plus x2 is equals to 0. So we have two equations. Now the question is how to find the values of x1 and x2. Say x1 is equals to, let say it is k. So x2 is equals to minus 2k. Therefore, the eigenvector x is equals to, say first eigenvector x1 is equals to, this is k 1 minus 2. This is k and minus 2. Similarly, we can find out the eigenvector for the value corresponding to lambda equals to 6. So we will consider the another case when lambda is equals to 6. So again this equation A minus lambda I into x is equals to 0. So 5 minus lambda 2 minus lambda x1 x2 is equals to 0. Now when lambda equals to 6, 5 minus 6, this is minus 1, 2 minus 6 is minus 4. Again simplify this equation. So this is minus x1 plus 2x2 is equals to 0, minus x1 plus 2x2 is equals to 0. Again 2x1 minus 4x2 is equals to 0. Now simplify these two equations. So this is 1 and 2. When x1 is equals to, let x1 is equals to, again say this k1, x2 is equals to, put the value of x1 here, is x2 equals to minus, this is plus 1 by 2 k1. Now another eigenvector, say x2 is equals to a1 1.5, or we can write x2 is equals to k multiplied by 2, 2, 1. So these are the two eigenvectors, that is x1 is equals to this and x2 equals to this, corresponding to the given two eigenvalues for the given matrix. So this is the entire process, how to find the eigenvalues and corresponding eigenvalues. We can apply the same method for a matrix of the order 3 by 3. And in the next video, we will discuss the application of these two eigenvalues and eigenvectors, that is scaling. Sure. Thank you.